Download this code from codegive.com, link in the description below. Troubleshooting pgadmin 4, connection timeout expired errors. The connection timeout expired error in pgadmin 4 indicates that pgadmin 4 couldn't establish a connection to the PostgreSQL server within the configured timeout period. This is a common issue that can be frustrating, but it's usually solvable by systematically troubleshooting the possible causes. This tutorial provides a comprehensive guide to diagnosing and resolving this problem. Understanding the problem *. Before diving into solutions, it's crucial to understand what's happening. When you attempt to connect to a PostgreSQL server through pgadmin 4, the following sequence generally occurs. 1. pgadmin 4 initiates a connection request *. It sends a request to the PostgreSQL server on the specified port, typically 5432. This request contains information like the username, password, database name, and other connection parameters. 2. Network communication *. The network infrastructure, your local machine, network switches, routers, firewalls, facilitates the delivery of this request to the PostgreSQL server. 3. PostgreSQL server processing *. The PostgreSQL server receives the request and verifies the credentials. It checks if the user exists, if the password is correct, and if the user has permission to connect to the specified database. 4. Connection establishment, or rejection. If the credentials are valid and the server is willing to accept the connection, it establishes a TCP/IP connection with pgadmin 4. If the credentials are wrong, or the server is configured to reject the connection, it sends a rejection message. 5. pgadmin 4 receives the response *. pgadmin 4 expects to receive a confirmation message from the server within a specific timeout period. The connection timeout expired error arises when pgadmin 4 does not receive a response from the PostgreSQL server within the allocated timeout. This can happen due to various reasons, which we will explore below. Common causes and troubleshooting steps *. Here's a breakdown of common causes and detailed steps to troubleshoot them. 1. Incorrect connection parameters *. The most frequent cause of connection problems is incorrect connection parameters in pgadmin 4. Double-check these parameters meticulously. *hostname/address *. Is it correct? Ensure you're using the correct IP address or host name of the PostgreSQL server. If PostgreSQL is running on the same machine as pgadmin 4, localhost or 127.0.0.1 should work. If it's running on a remote server, use the server's IP address or fully qualified domain name, FQDN. *DNS resolution *. If you're using a host name, ensure your machine can resolve it to the correct IP address. You can use the ping command in your terminal/command prompt to verify. If ping fails to resolve the host name, check your DNS settings. *typos *. Even a small typo in the host name can prevent the connection. *port *. Is it the default, 5432, or a custom port? PostgreSQL typically uses port 5432 by default. If you've configured PostgreSQL to listen on a different port, ensure you specify it correctly in pgadmin 4. Database name *. Does the database exist? Make sure the database you're trying to connect to actually exists on the PostgreSQL server. Correct spelling *. Double check for typos in the database name. Username/password Is the username valid? The username must exist on the PostgreSQL server and have the necessary privileges to connect to the specified database. Is the password correct? Passwords are case sensitive. Try entering the password manually instead of copying and pasting, to avoid potential errors. Consider resetting the password if you suspect it's incorrect. See later steps. *SSL mode *. Do you need SSL/TLS? If your PostgreSQL server is configured to require SSL/TLS connections, you need to configure the SSL mode setting in pgadmin 4 accordingly. Example require, verify CA, verify full. If you're unsure, try setting it to prefer to see if that allows the connection. Example, verifying connection parameters. Let's say your PostgreSQL server is running on a remote machine with IP address 192.168.1.100, uses port 5432, has a database named mydatabase, and a user named myuser with password mypassword. Here's how the connection parameters would look in pgadmin 4. *name*, any descriptive name for the connection, example my PostgreSQL server. *host name / address * 192.168.1.100. *port * 5432. *maintenance database * Postgres, or mydatabase, either is acceptable for initial connection. *username * myuser. *password * mypassword. *SSL mode * try prefer initially, then adjust based on your server configuration. 2. PostgreSQL server not running or unreachable ***. The PostgreSQL server must be running and accessible from the machine where pgadmin 4 is running. *** Is PostgreSQL running? Check if the PostgreSQL service / process is running on the server. The method for doing this depends on your operating system. *Linux, systemd. *Linux, sysvinid. *Windows * open the services application, search for services in the start menu, and look for a service named PostgreSQL or similar. *Mac OS * check activity monitor for a Postgres process or use pg_ctl status in the terminal after navigating to the PostgreSQL bin directory, example /library /postgresql /15/bin. If PostgreSQL is not running, start it. *Linux, systemd. *Linux, sysvinid. *Windows * right-click the PostgreSQL service in the Services application and select Start. *Mac OS * use pg_ctl start or start the PostgreSQL service through the graphical interface if available. * is the server reachable over the network? Use the ping command from the machine running pgadmin 4 to test basic network connectivity to the PostgreSQL server's IP address. If ping fails, there's a network connectivity problem. Check network cables, routers, firewalls, and DNS settings. ** is the server listening on the correct port? Verify that PostgreSQL is configured to listen on the expected port, usually 5432. Check the postgresql.conf file for the port setting. The location of postgresql.conf depends on your operating system and PostgreSQL version. Common locations include *Linux */ etc /postgresql /version /main /postgresql.conf. *Windows *c \program files \PostgreSQL \version \data \postgresql.conf. *Mac OS */library /postgresql /version /data /postgresql.conf. Restart PostgreSQL after making any changes to postgresql.conf. Is the PostgreSQL server overloaded? If the PostgreSQL server is under heavy load, example running long queries, high CPU utilization, disk I/O bottleneck, it might be slow to respond to connection requests, leading to timeouts. Monitor the server's resources, CPU, memory, disk I/O, to identify potential bottlenecks. Use tools like Top, Linux/Mac OS, or Task Manager, Windows, to monitor resource usage. Tools like pg_stat_activity, queryable from pgadmin4, once connected, can help identify long-running queries. 3. Firewall issues ****. Firewalls can block incoming connections to the PostgreSQL server. You need to configure the firewall on both the PostgreSQL server machine and the machine running pgadmin4 to allow connections on the PostgreSQL port, typically 5432. Server-side firewall ***. This is the most common cause of connection timeouts. Configure the firewall on the PostgreSQL server to allow incoming TCP connections on port 5432 from the IP address of the machine running pgadmin4, or from any IP address. If you want to allow connections from anywhere, use with caution. **Linux, iptables. **Linux, firewalled. **Windows firewall **. 1. Open Windows Defender Firewall with advanced security. 2. Click Inbound Rules in the left pane. 3. Click New Rule in the right pane. 4. Select Port and click Next. 5. Select TCP and enter 5432 in the specific local ports field. Click Next. 6. Select Allow the connection and click Next. 7. Choose the network profiles that apply, example domain, private, public. Click Next. 8. Enter a name for the rule, example allow PostgreSQL, and click Finish. Client-side firewall **. The machine running pgadmin4 might also have a firewall that's blocking outgoing connections to the PostgreSQL server on port 5432. Configure the firewall on the client machine to allow outgoing TCP connections to the PostgreSQL server's IP address on port 5432. The steps are similar to the server-side firewall configuration, but you'll create an outbound rule instead of an inbound rule on Windows. Network firewalls *. If there are firewalls between the pgadmin4 client and the PostgreSQL server, example a hardware firewall or a cloud provider's firewall, these firewalls must also be configured to allow traffic on port 5432. This often requires coordination with network administrators. 4. pg_hba.conf configuration ***. The pg_hba.conf file controls client authentication and access control in PostgreSQL. It specifies which clients are allowed to connect, using which authentication methods. Incorrect settings in pg_hba.conf can prevent pgadmin4 from connecting. Check the pg_hba.conf file **. The location of pg_hba.conf is usually the same as postgresql.conf. Open the file in a text editor. Ensure there's an entry that allows connections from your client. Look for an entry that matches the following criteria. Type *host, for TCP/IP connections, or host slow, for SSL/TLS connections. Database *. The database you're trying to connect to, example all for all databases, or the specific database name. User *. The username you're using to connect, example all for all users, or the specific username. Address *. The IP address or network range of the client machine running pgadmin4. You can use 0.0.0.0/0 to allow connections from any IP address. Use with caution for security reasons. Use 127.0.0.1/32 for local host connections. Use specific IP addresses or CIDR notation, example 192.168.1.0/24, for specific network ranges. Authentication method. The authentication method used for verifying the client's identity. Common methods include trust, allows connections without a password, insecure, use only for trusted networks. MD5, uses an MD5 encrypted password. Password, uses a plain text password, very insecure, avoid using. Scram SHA-256, uses salted challenge response authentication mechanism with SHA-256 hashing, more secure. Preferred method. Peer, uses the operating system's user identity, only works for local connections. Ident, uses the ident protocol, rarely used. PAM, uses pluggable authentication modules, PAM, for authentication. Example pg_hba.conf entry *. Order matters pg_hba.conf entries are processed in order. If there's an earlier entry that rejects the connection, later entries that would allow it will be ignored. Make sure the entry allowing connections from your client is placed before any entries that might block it. Reload postgresql after making changes to pg_hba.conf, you need to reload the PostgreSQL configuration for the changes to take effect. Do not restart the PostgreSQL server, as this can cause downtime. Use the following command. 5. Connection timeout settings ***. The default connection timeout settings in pgadmin 4 might be too short for your network environment or server load. You can increase the connection timeout values. pgadmin 4 settings *** in pgadmin 4, go to File - Preferences - Paths - Binary Paths. Then navigate to Preferences - Connection - Preferences and adjust these settings. Connect timeout **. This specifies the maximum time pgadmin 4 will wait for a connection to be established. The default is usually 10 seconds. Try increasing it to 30 or 60 seconds. Idle session timeout *. This setting determines how long an idle connection can remain open before pgadmin 4 closes it. If you're experiencing frequent disconnect ions after periods of inactivity, you might want to increase this value. PostgreSQL TCP_keep_alives_ settings, advanced in rare cases, adjusting TCP keep alive settings on the PostgreSQL server can help. These settings control how often the server checks if a client connection is still alive. These are set in postgresql.conf. Note: incorrect adjustment of these settings can negatively impact performance. TCP_keep_alives_idle, how long, in seconds, the connection can be idle before the server starts sending keep alive probes. TCP_keep_alives_interval, the interval, in seconds, between keep alive probes. TCP_keep_alives_count, the number of keep alive probes that can be lost before the server considers the connection dead. Example, in postgresql.conf. This will make the server check after 60 seconds of idle time, then send probes every 10 seconds, and close the connection after 5 failed probes. Reload PostgreSQL after changing these settings. 6. Authentication problems ***. Even if the username and password are correct, there might be issues with the authentication process itself. Password encryption. PostgreSQL versions have different default password encryption methods. Earlier versions used MD5, while newer versions default to SCRAM SHA-256. If you upgraded your PostgreSQL server but the user account still uses the older MD5 encryption, pgadmin4 might have trouble authenticating. Resetting the PostgreSQL user password. If you suspect the password is incorrect, or if you want to ensure that the user account is using the SCRAM SHA-256 encryption method, reset the password. 1. Connect as a super user. You need to connect to the PostgreSQL server using an account with super user privileges, example the Postgres user. If you can't connect through pgadmin4, you might need to use PSQL, the PostgreSQL command line client, on the server itself. To run the alter user command *, use the following SQL command to reset the password. Replace my user with the actual username and new password with the desired new password. If you want to force the user to change their password on their next login, you can add password expire to the command. 3. Update pgadmin4 *, update the password in the pgadmin4 connection settings to the new password. 7. Network issues ***. While the ping command can verify basic network connectivity, there might be more complex network issues affecting the connection. MTU issues * maximum transmission unit, MTU, issues can sometimes cause connection problems, especially over VPNs or networks with unusual MTU configurations. Try reducing the MTU size on the network interface of the machine running pgadmin4. The process for changing the MTU varies depending on the operating system. VPN problems *. If you're connecting to the PostgreSQL server through a VPN, the VPN connection might be unstable or have configuration issues. Try disconnecting and reconnecting to the VPN, or investigate the VPN's logs for errors. Proxy servers *. If you're using a proxy server, ensure that pgadmin4 is configured to use the proxy correctly, and that the proxy server is configured to allow connections to the PostgreSQL server. pgadmin4 doesn't directly support proxy settings through the GUI, however you may be able to configure the OS to use a proxy which pgadmin4 will inherit. 8. pgadmin4 bugs or corruption ***. While less common, pgadmin4 itself might have bugs or configuration issues that are causing the problem. Upgrade pgadmin4 *. Make sure you're using the latest version of pgadmin4. Newer versions often include bug fixes and performance improvements. Reset pgadmin4 configuration *. If you suspect that the pgadmin4 configuration is corrupted, you can try resetting it to its default settings. This process varies depending on how pgadmin4 is installed, desktop application or web application. For the desktop app, usually removing the pgadmin4 settings folder will do the trick, although this depends on the OS. Consult pgadmin4 documentation for details. Reinstall pgadmin4 * as a last resort. Try completely uninstalling and reinstalling pgadmin4. 9. Resource limitations on PostgreSQL server. If the PostgreSQL server is running on a virtual machine or a server with limited resources, it might not have enough resources to handle incoming connections promptly, leading to timeouts. Monitor server resources * use tools like Top, Linux/Mac OS, or Task Manager, Windows, to monitor CPU, memory, and disk I/O usage on the PostgreSQL server. Increase resources * if the server is consistently running near its resource limits, consider increasing the resources allocated to the server, example more RAM, faster CPU, faster storage. Optimize PostgreSQL configuration. Review and optimize the PostgreSQL configuration parameters in postgresql.conf to improve performance and resource utilization. Parameters like shared_buffers, work_mem, effective_cache_size can significantly impact performance. Example, using PSQL to test connectivity, command line. If you're still having trouble connecting through pgadmin 4, try using the PSQL command line client to connect directly to the PostgreSQL server. This can help you isolate whether the problem is with pgadmin 4 or with the PostgreSQL server itself. 1. Open a terminal/command prompt *. 2. Use the PSQL command *. Replace *192.168.1.100 with the PostgreSQL server's IP address. *5432 with the PostgreSQL port. *MyDatabase with the database name. *MyUser with the username. You'll be prompted to enter the password. 3. If PSQL connects successfully *, this indicates that the PostgreSQL server is running and accessible, and the username and password are correct. The problem is likely with pgadmin 4 itself. 4. If PSQL fails to connect *, the error message from PSQL can provide valuable clues about the cause of the problem, example connection refused, invalid user, password authentication failed. Troubleshooting checklist *. Here's a summary checklist to guide you through the troubleshooting process. Verify connection parameters, host name, port, database, username, password, SSL mode. Ensure the PostgreSQL server is running. Ping the PostgreSQL server's IP address to check basic network connectivity. Check the server-side firewall to allow connections on port 5432 from the client IP address. Check the client-side firewall to allow connections to the server IP address on port 5432. Review the pg_hba.conf file to ensure connections from the client are allowed. Reload PostgreSQL after modifying pg_hba.conf. Increase connection timeout settings in pgadmin 4. Reset the PostgreSQL user password. Test connectivity using PSQL from the command line. Check for VPN or proxy server issues. Upgrade pgadmin 4. Reset or reinstall pgadmin 4. Monitor PostgreSQL server resources, CPU, memory, disk I/O. Optimize PostgreSQL configuration. By systematically working through these troubleshooting steps, you should be able to identify and resolve the connection timeout expired error in pgadmin 4. Remember to be patient, double-check everything, and use the error messages as clues to guide your investigation. Good luck.